All right, my friends, here we go again. So more on solving linear inequalities. So what we're going to do today is we're going to work with our first type of compound linear inequality called an OR compound inequality. Now, just like in your LA class, when you have a compound sentence, all you are doing is connecting two different sentences, right, with a comma and a conjunction. All right, we're doing basically the same thing today. So the good news is there's nothing new to teach you. All right, mechanically, where all the mechanics of solving our inequalities are exactly the same. All right, all we have to do is show you how to, all right, connect those two inequalities. So to get you thinking, all right, let's do the opener here. There are two different inequalities that I want you to solve here. All right, so solve part A and part B. So pause the video. All right, work both those problems. All right, draw your answer in your number line. Write your inequality that represents that. Turn the video back on, and we'll see how you did. All right, so now let's look at the work for those two. All right, so when we solve the first one, we get our anchor is 3. All right, and you can see I have a solid dot on 3 because I'm greater than or equal to. Now notice when we test 0, we get a false statement. So this side is false, this side is true, so I'm going to shade to the right-hand side. All right, when you solve part B, hopefully you got that your anchor was -9. All right, once again, when you test 0, we got a false statement for 0, which means that this side would have to be the true side, so we're shading to the left this time. All right, so looking back at this one, our inequality would be x is greater than or equal to 3. Our inequality here would be x is less than or equal to -9. All right, so just two separate problems. All right, so now, like I mentioned earlier, all right, we're doing OR compound inequalities. So here's all that's going to happen. We're going to now just take two inequalities and have them in the same problem. So what if, all right, what if we had this, right? So notice it's the same inequality here. It's the same inequality here. But now we have this OR. It's 2x minus 5 is greater than or equal to 1, or -9x minus 7 is greater than or equal to 74. So here's all we do. We just do both problems just like we did before. And all that's going to happen is that the end result will be on the same number line. So when we look at this, all the compound inequality does is means we have to work two problems and then combine them on the same number line. All right, so notice x is less than or equal to -9. I would just have that here. Right? X is greater than or equal to 3. I have that here. So then our solution is two inequalities. X is less than or equal to -9, or x is greater than or equal to 3. So that's all the compound inequality is doing. It's just taking two inequalities and linking them, all right, to where we have both of them on the number line. All right? And just mathematically, when we think about an OR statement, all right, with an OR statement, all right, it's either this or that. As long as one of those particular things is true, then the whole thing is true. All right, so I can pick a number over here, or I can pick a number over here. All right, we're going to talk about an AND next time, and it's a little different with an AND. All right, but for an OR, I can either have a number here or over here. All right, so that's all an OR compound inequality is. All right, so how do we solve this? What are we going to do? Right, we're going to solve for our anchors exactly like we did last time. And just instead of having one anchor, we are now going to have two anchors. All right, we're going to mark those, all right, with our inequality symbol, or excuse me, with an open circle or a closed circle based on an inequality symbol. So we could have two open circles, or excuse me, two closed circles. We could have two open circles. We could have one of each. All right, so we're going to base it on the inequality just like what we did before. Once again, we're going to test. All right, we've got to figure out which way to shade, and we just have to do that twice. All right, and then the difference is when we write our inequality, we're now going to have this OR in between because we're going to have two different, all right, inequalities on our number line. All right, so let's take a look at some work here. So let's flip the page. And all we're going to do first here is just go through a few graphs, all right, just working on writing, okay, working on writing those inequalities. Now, once again, it's really just two problems. So what I'm going to do now is I'm just going to not look at the right side. I'm just going to look at this inequality right here. All right, my anchor is 0, it's open, and I want all the numbers to the left of 0. Well, that would just be x is less than 0. All right, now I'm going to look at the right side here. Cover up the left side. Okay, my anchor is 5. It's a solid circle, and I want all the numbers to the right of 5. So those numbers are all bigger than 5. So I'd want x is greater than or equal to, since we have that solid dot, 5. And now it's an or compound inequality. And that's all this is, right? It's just working two different pieces and connecting them. All right, so if we look at number 2, all right, if I look at number 2, once again, I'm just going to cover up that right side for now. I'm going to focus on this. My anchor is -9. I'm in the middle between -8 and -10. All right, it's solid. And I want all the numbers to the left, or less than -9. So I want x to be less than or equal to -9. All right, and then now I'd look over here at this inequality. All right, I have an open circle on my anchor of 2. All right, and then I want all the numbers bigger than 2. So that would be or x could be greater than 2. And that's really all that is. All right, so now let's just look at number 3. And once again, we're just going to go piece by piece. All right, so when I look at my left side here, my anchor's at 0. I want all the numbers to the left of 0. All right, so that means I want all the numbers that are less than 0. Or I look at this side, now I have an anchor at 3, it's solid, and I want all the numbers bigger than 3 or greater than 3, so x could be greater than or equal to 3. All right, and then we look at number 4. Once again, if I just look at the left side, we have an anchor at 7. I want all the numbers less than 7 to the left of 7, so that would be x is less than 7, open circle there, right? Or we could tap some of the numbers on the right side. So when I look at that, my anchor is 10, and I want 11, 12, 13, 14, any of those numbers out to the right. So if I'm going to the right, those numbers are all bigger or greater than, or x can be greater than 10. All right, so that's all we're doing. Now, so here's where the work comes in, because now this is kind of the final step. This is what we end the problem with, right? So now we have to get to that by doing the algebra, which is exactly the same algebra that we did last time with solving inequalities. All right, so if we look at number 5, right? Here's my first inequality. I am not even concerned with anything over here yet, okay? It really is just two separate problems, right? So I'm going to just follow what I did last time. So the first thing we said last time was write it as an equation. So -4x minus 9 is equal to -13. And we want to solve for that anchor. So I'm going to add 13 to both sides. All right, so -4x plus 4 is equal to 0. I'm going to use my cover-up method. What plus 4 is 0? -4 plus 4 is 0. So that means -4x has to equal to -4. And then that means that, all right, x has to equal to 1. So -4 times 1 is -4. So that means my first anchor is 1, which is right here. All right, and it's going to be a solid anchor because of the less than or equal to. All right, and so now, once again, just like we did last time, we're going to pick 0 and we're going to test. So I'm going to take 0 and I'm going to plug it in and see if I get a true or false statement. So -4 times 0 minus 9 is less than or equal to -13. All right, -4 times 0 is 0. All right, so I get -9 is less than or equal to -13. Well, that is a false statement. That is false. All right, -9 is not less than -13. So 0 is on the false side. So to the left of this is false, which means I want to shade to the right. Okay? All right. And if this were what we did last time, we would be finished. We would be done. We'd write our inequality. All right? So now, though, we're not done because we have an or here. Or it could be that. So once again, I'm not going to concern myself with what happened over here. Right? I'm going to ignore that. I'm going to work this as a completely separate problem. So we're going to go through that process. So 7 minus 3x equals 25. All right? So subtract 25 from both sides. Get it equal to 0. So -18 minus 3x is equal to 0. All right? So now I cover that up, right? So -18, if you can see that there, -18 plus what is 0, which would be positive 18. So -3x has to equal to positive 18. Now, -3 times what is positive 18? That would be x equals -6. So there's my second anchor. All right, once again, I go back to my inequality symbol. It's greater than or equal to. So I'm going to have a solid dot on my anchor. And then once again, let's test 0. All right, so 7 minus 3 times 0 is greater or equal to 25. Well, -3 times 0 is 0. So this would be just 7 is greater than or equal to 25. Well, 7 is not greater than 25. That's false. So that means 0, all right, 0, and if I ignore this right here, right, that's not really there. So 0 is false, right? It's false. That's on the right side. So everything on the right side is false, which means the true side has to be to our left, and there it is. All right, and so now there's our problem. And notice now we're like what we did up here. We have to write those two inequalities. So my first one, this would be x is less than or equal to negative 6, or x could be greater than or equal to 1, just like that. All right, and that really is all it is. All right, just working two separate problems and then combining them at the end. All right, so let's look at number 6. Let's look at number 6 together. So once again, all right, I'm just going to slide this over. I'm going to ignore everything over there because that doesn't matter right now. So we just want to solve this particular problem. All right, so 2 minus 6x is equal to negative 40. All right, add 40 to both sides, so plus 40 and plus 40. Let me hit the focus button for you guys here. Bring that back into focus. There we go. All right, so 42 minus 6x is equal to 0. All right, so 42 minus what is 0? All right, would be 42. So, all right, 6x would equal to 42. All right, now 6 times what is 42? And that answer would be 7. So there's our first anchor. It would be 7. All right, now, once again, I'm going to go back up here. Now, I know this anchor is going to have an open circle because it's less than. So I'm going to put an open circle on 7 here. All right, and then we want to test 0. Now, 0 is on the left side this time. So if I go back to my inequality here, 2 minus 6 times 0 is less than negative 40. All right, 6 times 0 is 0. So I'm left with 2 is less than, all right, negative 40. All right, 2 is not less than 40. That's a false statement. So 0 is on the false side. So everything to the left of 7 is false, which means to the right is the true side. All right, so there's half of our problem. All right, so now let's jump over and look at this problem. All right, so once again, we're going to start by just writing the equation and solving for our anchor like so. All right, there we go, back into focus. All right, so now I'm going to add 37 to both sides. So 8x plus 32 is equal to 0. Cover it up. Okay, so what plus 32 is 0? Negative 32. So 8x is equal to negative 32. Now, 8 times what is negative 32? Negative 4. All right, so there's my second anchor. And then I know it's going to have an open circle. When I go back to my inequality, it's less than. So negative 4 is going to have an open circle. All right, and then once again, now we have to test. I'm going to plug 0 in. So 8 times 0 minus 5 is less than negative 37. All right, 8 times 0 is 0, and so I get negative 5 is less than negative 37. All right, that is a false statement. So that means 0, 0 is on the false side right here. All right, so that means that we want the true side, which would be to the left here. And there it is. All right, and now all we have to do is write those inequalities. So I want all the numbers to the left of negative 4, which are less than that. So x is less than negative 4. Or I want all the numbers to the right of 7, which is greater than 7. So x would be greater than 7, just like that. All right, and that's how we solve, all right, or compound inequalities. All right, so be sure to do your video check-in, and we will pick up with more of these in class when I see you. Have a great night.